Welcome everybody to my talk about the 5 basic topics you should know about Project Reactor. So this talk is going to be about, as the title says, about just the basics of Project Reactor and reactive programming. I believe there is also a talk later today that it goes more in depth in about Spring Web Flux. So if you're interested in really how to make an application based on Project Reactor, this is not that. We're going to really into how to work with the basics to make sure you, for example, don't run into any production problems while making your first reactor project. First of all, what is Project Reactor? But before I start, I do have some questions for the audience. I would like to know which one of you actually does reactive programming? Who does it? Quite a few, that's awesome. In any kind of way, it doesn't have to be Project Reactor, by the way. That is pretty good. So hopefully the rest of you who doesn't, hopefully you get to learn something today, and hopefully at the end of the day you have some tendencies to start experimenting with it. So as I said, what is Project Reactor? So first of all, it's an API based on the reactive streaming API that allows you to do 3 things. These are basically taken from the website projectreactor.io. First of all, it's about demand management. So basically an API that natively implements thread management for you, does something for your memory consumption, basically just making sure that no threads are in use that don't have to be in your environment. Second of all, it implements for you a type sequence. So whereas, for example, if you're familiar, for example, with TypeScript observables, they don't necessarily have to be typed in JavaScript, but in Project Reactor, obviously, because it's Java, it's strongly typed, so it allows you to create data streams that are strongly typed. We're going to get into what data streams really are and how they look like when we go later on into the coding demos. And last but not least, it gives you a non-blocking I/O API. What that means is basically it natively allows you to deal with back pressure issues. This is one of the main issues we had in our project while we started working with it. So that is what Project Reactor allows you to give. If you want more information about the project itself, you can go to projectreactor.io and you can read everything about the idea of the API. So let's get back to let's start with the story of my team. I work in Rabobank. A few years ago, we started working on our first cloud application. And as you might know, we didn't really have an idea on how to do that. As most of you, I guess, have the same problem. So we made our first application basically using pretty much the same ideas as what we used to build on-premise before that. We did, however, containerize it on Cloud Foundry because we were required to do so, and there were a few problems that were occurring. Most of all, it is a problem with back pressure, and basically we had a lot of data coming from various places, which caused the problem that we had to write a lot of technical code, like recursive tasks and threading interfaces. So we were working a lot with concurrency, which 50 or 60% of our coding time went into writing concurrency code. And we had our first application live, and first of all, it didn't work very well, but second of all, it took us a long time to write it. And improving it was a lot of technical improvements, a lot of technical depth in that as well. So we started looking at how do we want to improve it? How do we want to start writing code in cloud that allows us to make business code instead of just writing technical code? And we choose to go with Project Reactor to do that because it allows you just to write what should happen and not how it should happen. So basically right now our code is really, we don't write any more recursive tasks or a concurrency code. We just write the data streams. It basically explains what should happen, and the reactor basically gives the implementation based on what happens during when a customer requests some data. That will compute how it actually will happen, but I don't have to code it. But before I continue, there is also one thing: don't do reactor or reactive programming just because it sounds nice, because you're you're going to get yourself slipping on wet floor, because the time that is required to really get to understanding reactive programming really requires you to invest a lot of time. So don't underestimate it, experiment with it, discuss it, and make sure also your business is definitely on board with the requirements that it takes to do this. Within half a year, we were still not really up to speed with writing proper business code, writing proper production code, but after a few years we are there and we are really delivering very quickly now. So the time investment, don't underestimate it, and make sure you are really sure about getting started with this. So, but with that said, something about myself first. As I said already, I work at Rabobank. I'm a software engineer. I work for about 4 years now in Rabobank. I work in the online access management. Specifically, we are responsible for everything that happens online and offline in the bank or online in the business, and particularly with the power of attorneys in Dutch, volmachten, maybe for the Dutch people would make more sense, because that word, a lot of people don't know that word. But basically, we are for making sure that once you go into the app or in the bank, you are allowed to do what you should be allowed to do, and you are allowed to work on what you should be able to work on with your banking, whether it be business or private. So a little bit about myself. Since recently, I like to do blogging. I really like to just, if I have a few hours free time after developing something, just write something down. It really clears your head, and it's a really good way to understand what you did. Also, since today, speaking at conferences, my first time. So, but of course, I really like to do it a lot within the company as well. Some topics that I really enjoy is, of course, reactive programming. That should not need any explaining. And cloud native is also something that I like to write and talk about. A little bit about myself. I like to do running a lot. I do semi-marathons. This is a picture of me in the KWF run last October in Eindhoven, the semi-marathon. And I also like mud runs. This Saturday there is Mud Masters, and next week there is Strong Viking. If you're wondering where my t-shirt is from, you'll have to go through the mud. Unfortunately, you can't get them here. And a little bit about my private time. I'm really a big StarCraft fan, so that's something you can wake me up in the middle of the night for this later if you want to. So let's get started with a little introduction on what reactive programming really is, because basically when we were working on it for 2 years already, we basically started asking ourselves the question, what is actually reactive programming? Like, we know it works different than imperative programming, which is what most Java developers are used to doing. But how is it really different? And at that moment, you start understanding a little bit why your code is sometimes behaving a bit strangely. So the best description I could find is that reactive programming is a declarative programming paradigm concerned with data streams and the propagation of change. So there's 3 things that I want to highlight on it. Declarative programming paradigm basically means you're only writing the what and not the how. So you're writing a data stream that says it should get there, some data should there, it should do some operations, it should do some mapping or etc. But you're not writing code on how this application should do that. So that goes about the part about concurrency that I talked about. Data streams. So basically, I think the most simple way to describe what a data stream is just data across time. So you have, in the variable of time, you have data coming in different ways. We're going to look more into this. So what I use to describe the data stream is the RxJS pictures. So it's just very simple. I have 2 data streams. They are both streaming some data across time. You can see that the one on top will have a total of 5 data points, and the one in the bottom has 2, coming in different times. And you can do operations on those data streams and make changes to them. And basically, in this case, is an example of merging 2 data streams would result in a data stream down below. What is important to know is that in this case, because both data streams end at the same point in time, it also means that the last one ends. So how do we compare that with imperative programming? In reactive programming, basically, if I have a subscriber that is listening to the data stream down below, it should know that at that point in time, this data stream should end, and across the time, there have been some data points coming in. If I look at this imperatively, basically, I'm only looking at in one point in time. The subscriber, basically, for any of the streams, the value changes over time. Whereas in imperative programming, I basically have to say which point in time am I looking at this, am I equaluating this value. So I'm totally forgetting about the fact that I have changing values across time. So that's something about that is important. And that comes back also to the last part, the propagation of change. So what is really important in reactive programming, also when you're coding it, is that because you don't know, if you write a piece of code in reactive programming, especially for people who do a lot of JavaScript or TypeScript coding, there's a lot of moments where the execution doesn't go like top down, comparative programming. And that's something that the first time you start coding it, things are happening and you have no clue why it's turned around. Why is that? And that is because of the last part. Because very simply, in this case, if I do project reactor, the reactor found that doing the last part step, it was able to do it before the other one. So that is what you should know about reactive programming. And we're going to go into some coding demos where you can see basically how it works and how it feels, and I'll tell you more about it. But before I do that, probably you've seen this maybe many times, but I have to do it anyway, so let's go through it pretty quickly. What is important to know, especially in Project Reactor, it uses the publish-subscriber pattern. So in this case, there are actually three actors. There's the subscribers interested in a piece of data, there's the publisher that basically has a piece of data available, and in between there's a processor. Within Project Reactor, you do nothing with a processor. It's basically you just make publishers and you subscribe to them, and everything that the processor does is done for you, but you should know basically how it works. Because the thing is here that the subscriber and publisher, they never interact directly with each other, because that would basically be a blocking thing. So what happens is a few steps. So first of all, I need a subscription, which is it's not really an actor, but the subscription is the fourth interface in this story. Without a subscription, nothing ever happens, first of all. So if you write a piece of code, and you forget to subscribe to it, you'll be looking at your code and saying, why does it do nothing at all? You forgot to subscribe to something. Luckily, for the IntelliJ users below us, IntelliJ tells you when a piece of code is not subscribed to, so don't ignore that message. It's there for a reason. So, well, first of all, of course, point number 2, publisher could publish. It doesn't actually need to. We'll get to that in a moment. But if it does, it will publish a piece of value, and my subscriber can read it and do something with that. All right. So after that, as I said, 2 could happen. For the completion of the stream, must happen, but it can happen it could happen on both sides, but it must end at some point in time, but it could happen before any data is published. So that's really something important to remember, because we're going to go that into the coding examples. It could happen that nothing is published and the stream ends, and I have to do something with that. I cannot ignore it. It's a little bit different than exception handling, but it's a form of something that I have to handle in my code, because we used to not handle it sometimes, and we were basically bug fixing a lot until we realized it's just a publisher, it comes back as empty, and we're not doing anything with it. So these are only the points that I want you to remember about publish, subscribe. Now we're going to go into the coding parts. So first of all, let's see how this goes. Yes. We'll go station mode. It should be readable, right? Okay. So before I start, there are 2 publishers that Project Reactor basically has. There's basically only 2 interfaces that I write all my code with, and I use operators to work with them. There's the mono and the flux. So what's the difference? The mono is a type of interface that I use that publishes either 0 or 1. So it never publishes more than that. It always ends after 1, or it ends empty. And there's the flux, which basically publishes 0 to n times. It could publish infinite amount of times, but it also, every stream must end at some point. So let's have a basic look in how to set up a very simple publisher. Well, first of all, what you should know is that using mono to just, I can very simply just use a constant to create a publisher. It looks very stupid, but the whole idea why I start with this is because I want to introduce to you the step verifier, because when it comes to testing publishers, we have to actually learn a lot as well. In the beginning, what we were doing is basically just assert that on our block, and we just say, secret, don't do this. Don't do this. Just get it out of your head now. If you do this, you should get fired probably. Because why? Because basically what I'm doing now is I'm testing a reactive stream or a reactive application imperatively. I'm basically throwing out the window the idea of the propagation of change, the idea of time, and saying, this works, right? Just don't do it. We have better ways to do that. If you're writing a piece of reactive code, test it reactively. So for that, we use a step verifier, which is part of the reactor testing core. So it just comes with the package. I create a publisher out of something. I have to say for each value that is published, what should it be? I can put assertions in there. I can make it run a piece of code, or in this case, I just say it. I expect the value to happen, and I must always say now it should complete, because otherwise, what happens is basically what I've told about is basically IntelliJ saying you there's no subscriber, so it comes back to the point that I started with. Without a subscriber, this piece of code does nothing. So we could run this code and say, okay, that looks nice. Well, great. But this is this code, and that's point number one. This code is not null safe. So what we should do, because who creates publisher out of constants? It's nonsense. It's not really just because there is a piece of code doesn't mean you have to make a publisher out of it. It's not a thing, but. The thing is, once you have a piece of code that you are not sure if maybe it's nullable, if it can be null, you should never just use mono.just or flux.just. Never do that, because you can run into production into the problem that a null value does come, and maybe you think like, it's probably able to deal with that. It's not. It doesn't like it at all. That's why we have to make sure that we tell the reactor this value is nullable. I can use optionals as well with this just or empty. And then, of course, what happens if a null value comes? It will come back empty. And we have to deal with that once again, but we're going to come back to that in point number 3, I believe, from my head. So stick with me for a moment. We're going to look at empty streams in a moment. The same thing happens with Flux. I can use, of course, with a Flux. Now, the thing is, I can test each individual value. And within that, it's basically the same thing. There's no just or empty here, because basically, how it comes with a Flux, basically, I should convert it from iterables or collections or that. So I've introduced a just or empty. I can use optionals for that. So if you have optional interface somewhere, don't start rewriting it into project reactor, because you don't need to. Just put it right there. All good. As you can see, when something is null, yeah, use optional. It doesn't like that. So the last part about this topic, if I have a collection of any kind, use from iterable to convert it. Don't start putting individual values in it or something. There's a set of interfaces that just allows you to, from streams, iterables, convert it right away. Also, if for some reason you need the entire list at once, don't just convert it collect list, and you will have a mono of a list. There are cases where this is needed, and then I can, in this case, for example, if I want to test this size, I could do it like this. From stream, I think that's the most important thing that I want to explain for this part. So always make sure you are null safe or convert them from collections or streams. Just gonna look at the time for a moment. Okay, it's pretty good. Okay. So now I have a very, very basic stream. Now what can I do with him to write code? So If I want to convert streams between different types, between mono and flux, and do something with the values, there's a few different interfaces available to do that. And mostly we do that by converting or zipping them together. So for example, I have two pieces of data and I want to do something that uses both of them. So what I've seen the developers do who just started doing reactive programming on their first day, they just block both of them and create a new publisher. Fortunately, there's a better way to do that. So very simply, for example, I have a flux that streams a few pieces of data, and I have a mono that has just one, and I want to do some kind of operation that uses the value from this mono in every flux value. I could zip them together. Now what that creates is, I know maybe some people will look at this and say, tuple, really? This is just about a demo. If you use Java 17, just start using records. It would be very nice. You can also, every zip interface also has a combinator added to them that allows you to convert them into like a record class or just create your own class. But for the demo purpose, I'm just using tuples. But it does, in some cases, create some code that is not perfectly well readable, which is also still something we are experimenting with. But I think by the time we finally move to Java 17, if all the tooling is available, I think we're going to look into records instead of tuples. I was looking at a clean code talk from Victor and Theo a while ago, and he was not happy about it, so I thought I should probably mention it, otherwise I'm going to get flamed for showing tuples. Just know that there is a better way to do that. Now, the problem that I wanted to show with this is I have to understand that if I have one publisher that publishes 4 times, now it's blocking the rest of the code, and the other one's just doing once, if I zip them, what happens? I only have one value coming out. So line 150, I'm expecting next count just 1. Well, why is that? Because the mono publishes just once. Just because I zipped it with a flux, it doesn't just publish 4 times. Mostly you would expect it would maybe do that because it should understand that mono doesn't know the other one is publishing 4 times. It doesn't know that. If I want to do that, I have to say, okay, repeat the mono, which eventually what it does, it changes it into a flux that just keeps on publishing endlessly. And because I zipped them together, because the first one ends after 4, it will end after 4 instead of going indefinitely. So that way, I make sure that if I want to use that value for each of the flux, I have to repeat it, otherwise I will just have one value. As I said, you can use a combinator as well. In that case, of course, and yes, I can just write this a bit better. Doesn't really matter what I do. But in this case, I don't have a tuple anymore. But in some cases, obviously you can't do that. So using records or just using defining classes would be a nice way. But mostly for flux 2 is not really a problem. But if you have a flux 4 or 5, maybe you should do it. The other way around, I can also do it. Flux a mono with a zip width. Basically, in this case, what I'm saying is it basically comes down to the same thing again. Normally, if I zip them together, basically there will be just one value, unless I do the mono dot repeat again. But I can also just pick the first value of the flux. What if I have more than 2? It's the same idea. Whichever publisher ends first, basically will be how many values I'll have, unless I decide to repeat one of them. So if I just zip them together, there will be just one value, with a tuple in this case. If I repeat the mono, it will end after 2, because this one has 2. So
zip means just combine.
Yeah, it just combines the two. Basically, it's if you look back at the, basically it's almost the same as this. Instead of a merge, basically puts each value separately. And what a zip does is it just puts like the first value together with the first value, this one with that, and then it ends. And it basically, in this case, you would get a tuple of 20 and 1 and 40 and 1. Or if you use a combinator, like add them together, you would get 21 and 41. And then it ends, because there's no third value here, so it can't do anything with the 16. So that's That's how basically how it works. So let's get to the third one. This is where I was introducing earlier. What if they come back empty? So what we do if we have publishers that come back empty is we are switching, because we are basically going to a alternative publisher or an alternative piece of data. It's important to know that if I write an application, basically everything can be considered as one big data stream. There has to be at least one place in every data stream where you have some kind of switch that says what should happen if it's empty. Because as I said, if it's not, your application just gets stuck and crashes. And that is just in reactive programming, basically one of the really the newest things that happen when you're coding, because it's something that just, doesn't really happen in imperative programming. So I have basically, I have to have an empty mono and empty flux. So they basically just, when I construct them, they immediately call the onComplete. And what I say is, okay, if it's empty, then switch to another publisher. Switch if empty, mono just one. So what happens, it's empty, and instead, it will switch to the other data stream. So in this case, I have two values, one for the mono, one for the flux, do the exact same, they switch to the alternative. So in this way, I have prevented from the empty publishers from crashing and getting the whole application stuck. What you should know about this publisher is that it's being constructed ahead of time and called upon when it's actually empty. I'm gonna go back in what that means later on here. I can use default of empty as well. The difference is that instead of supplying a whole new data stream, I'm supplying just one data. I'm just publishing that piece of data instead. So I'm not giving a whole new a publisher. I'm just giving now publish this value instead. I'm not switching to a whole new publisher. But in this case, if I say default of empty one, it's basically the same thing. But if I, for example, the first one, if I, for some reason, I want to publish something of another type, I could only use the first one. But in this case, if I want to publish a default value, which in production I don't think is a very good thing to do. If the customer for some reason can't see the data, just show a default piece of data. Not a good thing to do. I can also switch, not if it's empty, but if I meet a certain, if I meet a certain signal. So if I say once the value reaches a certain value, then switch to a new publisher. So this switching can also happen, you can also do it when it's not empty. This allows me to basically say, if I'm just looking inside a piece of data, when it reaches a certain threshold, then do something, write a log, write a piece of data, or I'm not interested in everything that comes behind it, just end it there, end the subscription, and go about whichever switch you are interested in, what it should do. So this part, very important. What I talked about in the beginning is that if I write a switch statement, is that publisher is being initialized ahead of time. It's being constructed ahead of time. Only called upon later on. But if I have, for example, if I have something like a log statement inside a switch of empty, I just want to log like, hey, something really strange happened here. What will happen is that log line is being written in your code, even if the switch is empty, switch of empty didn't happen. Because it's constructing ahead of time, the log line is being written at that moment, even though it doesn't publish something, that piece of code is already being constructed. So we've had this happen in production where we have log lines saying this customer, there's a problem, we are looking at, there's no problem at all, I can't find it. So you have to use defer. When you have a piece of code in a switch that basically could do something that you really don't want to happen ahead of time, add defer to it, because that means that only when the switch is being called, only then it will initialize this publisher. So in this case, I can see if I add defer to it and this publisher is not empty, there will be no interactions with this mock service because I don't want it to do that. I can also return errors because I can imagine at some points something has to return a piece of data. What do I switch to? Well, it's probably just an error, right? So actually the next part, again, we'll talk about handling errors, so it's kind of go to the next part. I can just add a mono.error and just put an exception like usual in that. And then basically it will just reactively within the metadata, it will send an error through. All the interfaces, all the subscribers subscribing on this error will basically forward that error back to whichever is in the front, right? Your REST API or Kafka listener or whatever. It works really like you're used to in just exception handling, but I have to work a little bit different with the actual error, which is a nice bridge to the next part, is the error handling. So, unfortunately, I have to still write exception handling. If you were hoping that you didn't need to do that, I have to disappoint you, but it should be expected. So I have written just a publisher that instead of publishing, in this case, an integer, publishes right away an error. And there's a few different things that I can do. I can once again return a default value. So if an error happens, just return the value 1. I can return a completely different error sorry, that's not right what I said. I can return a value only for this exception. So if I say, if this kind of exception happens, actually it's fine, just return this and continue business as usual. I can also, instead of looking at the exception class, I can say if a message containing something that really, whatever, is not a problem, then return a fallback value. I can also choose the same, all three, always on a certain exception or on a certain condition. I can resume with the alternative publisher if a certain error happens. So in that way, I'm just saying you could do something like if an error happens in this database and just return a publisher that calls something else, and hopefully there it works. And then there I could do the same thing again. For example, if it fails, then really just return the error. Something like that. I can apply maps as well. I can, for example, just map it into an error. If I say here, if I have a certain type of error, I can return something else. Or in this case, also use the constructor of that exception to make sure I don't lose the stack trace, of course. And also with condition as well. So as you can see, all of these operations in handling errors, they just have a set of interfaces that allows you to either look for all of them or the which type of exception, or just look at the message, for example. And last but not least, I can also just on error continue say, okay, if there's an error, do nothing with the error, but for example, write a piece of log statement, for example. Then it will do absolutely nothing, no mapping, no change the exception or something, but just do something when that error happens and then publish the same error back to the subscriber. Yeah, this one I'm gonna skip for now. Then we're going to talk about the last part, which is caching, which is something that we do also a lot in our landscape. So, what is important to know before I start talking about this one is when I create a publisher in Project Reactor, every time a subscriber calls upon a piece of data, it could be that that publisher is recreated. It is not guaranteed that the exact same data is being published to both subscribers. Because as I said, it's basically when something happens in time is not guaranteed. So it could happen in this case, I have just a normal mono like all of them, and in this case I have an atomic integer just to show that if I create 3 subscribers randomly on this, my atomic integer has been incremented 3 times. That is because for each subscriber added, it has reconstructed that publisher. How do I prevent that? Well, in a lot of cases you don't need to, because it's fine, but if you really want to make sure that if I'm doing more than one thing with the same publisher because of whatever reason, there are plenty of reasons that we have this in our code, I could decide to do 2 things. First, I could .cache the publisher itself. The way you should look at this, this doesn't like store a publisher in like a Spring cache or something. You know, we're going to get to Spring cache after. What this just does, it just says, if I have a second subscriber, use the exact same data stream as I used in the first one. I only construct it once. So it doesn't republish those values, it just gives the exact same. So in this case, the increment and get only been called once, because I'm using a cached data stream. In this case, I'm just also making sure that, hey, if I'm using it 3 times, and it's being constructed 3 times, that uses more resources really than it needs, and I don't want it to do that. So in this case, I'm just telling it reuse it, because otherwise I'm getting 3 data calls instead of 1, and that's unwanted. So if you do very expensive calls, in our cloud application is doing a lot of expensive calls. We basically also actively cache those like this, because just doing it multiple times only makes the application slow for absolutely no reason at all. If I'm looking for the name of a customer, this is not going to change between one subscriber and the other. It shouldn't, really. Might happen, but of course I can also, just like with any other application, I can choose to cache externally, which is also what we do. We use Hazelcast to cache externally. In this case, basically it's just a Spring cache implementation that just says any piece of data basically that we use in order to prevent it from going outwards from our application to our backend, which often is really 90% of the time that our application takes to run is between external calls. So the more we can prevent them, the better. So each separate external service, we have a specific time to live configured depending on the piece of data. Some of them are quicker because they change a lot. Some of them, like customer names, they are cached for a long time because we don't want these calls happening all the time. I'm still demoing this because I think it just gives a nice idea, but actually the cache mono, it used to be in the reactor add-ons. It's deprecated now. But I still like it, but of course in the future we'll just use the Spring cache again. But it just nicely demonstrates that if I look up something, I only run the piece of code if the cache is missed, and then write it with a certain publisher. Once again, if I call it 3 times, the atomic integer is only being called once. So it does the same thing, but in many cases, in our example, external caching is better than caching the publisher because you're caching it at the client level, basically. So the difference between the two, of course, the publisher cache happens on a real local level. That piece of code is publishing is caching that publisher. The externalized cache means if a customer makes multiple calls or I have a piece of data that multiple customers have access to, is being cached for all of them for a certain amount of time. So in this case, externalized caching just reaches a lot more, but it does make your code also a lot cleaner if you're looking at a piece of code where you say, hey, this is happening 3 times, but yeah, why would it? Even if I have to reach out to the cache 3 times, just don't do it. Because if you have no business use for that, then use the cache. So, thank you. That's all I have. That's all I have to tell you today.